We're also going to be able to describe how to prepare for the subjective estimation of probabilities, things that we typically do to help out teammates do that. Evaluate some ways to do it subjectively and understand ways to minimize bias, as well as identifying any pitfalls in documenting our results. And lastly, how to perform some coherence checks on subjective probabilities. So what is it? So subjective probability it's a type of probability that's based more on judgment, background, and experiences, as opposed to maybe say objective probability, which can be measured, right? Subjective probability, flipping a coin, we know it's going to be a 50% chance, right? Whereas subjective, you pull in more of that, your judgment, your background, your experiences to make those estimates. One way that I could describe this is if you have two meteorologists, they're looking at the same set of data, and they both give you different percentage chances of rain for tomorrow or the next day, right? They're both using their subjectiveness to decide what to assign for those numbers. So why do we use it? So when we work with dams and levees, typically there's limited statistical data to work with. We just don't have a lot of information regarding a lot of the things we work on. There's also the fact that a lot of our projects have not been significantly loaded, right? So for your example we just did, it only been loaded like 217. That's like 20 foot short of the spillway. That's pretty common, for a lot of the inventory. And in some cases, there's simply just not any analytical models for computing any of these probabilities, right? There's too many variables for some of these failure modes, and there's just no good way to make an objective estimate. So, this kind of leads to the question, how am I supposed to make an estimate when I really don't know what's going to happen, right? And so we know you don't know. That's why we want to make sure we're capturing our uncertainty. We're discussing our uncertainty in our SQRAs, capturing our uncertainty when we do quantitative risk assessments. It doesn't really require us to know to make an estimate, right? So, and it's really not, it's going to be an expression of what we know at that point in time. If there's new case histories or things that change or ways of evaluating things that change, if that's a point where we want to say, hey, we probably need to go back and rethink that, rethink about how we're doing this. Example is like when Oroville had that incident, right, with their spillway slabjacking, that kind of completely changed the seriousness and how we look at that failure mode now. All right, so making a probability assignment can be approached from two perspectives. You need to use inductive reasoning to do that. It's more of a top-down approach that's based more on available data and interpretation. It uses the logic of moving from cause to effect, kind of like our event trees, and it really kind of answers the question, so what happens if, right? So thinking this way can be difficult for a lot of engineers and scientists. A lot of us are used to having hard numbers, where we're calculating what's going to be the exact moment whenever that decides to break or whatnot in some of our analysis, and you kind of got to shift out of that method of thinking whenever you're making estimates for risk assessments. So there's two main things that we like to point to help get those that are going to be making estimates more of a background, and that's primarily comes down to frequency information, which is how often does something happen, how often something happened historically. And the other is causal information, which might be particular case history, an analysis, particular construction detail that we suspect could lead to a particular flaw or things like that. So throughout the week, we're going to be giving you some of these numbers for a lot of these different potential failure modes, both tomorrow and Wednesday. But you do want to be a little bit careful about some of this data that you're going to hear. A lot of that data was gathered from inventories that I would say are not as maybe as robust as some of the USACE inventory is. So just something to keep in mind. So preparation. So facilitation. So having a good facilitator is really going to aid the team in making good estimates. So listed here is just some of the experience that it's preferred the facilitator have. We've talked about this already. You want to make sure that there's been a very diverse team assembled. It's kind of up to the facilitator to ensure that's the case. And you want to try to keep that same facilitator through the entire process as well, meaning when you start with the PFMA session, having them there for that as well can be very, very beneficial. Another thing they're going to do is at the end, they're going to be able to, step back. Facilitators typically not making estimates and kind of evaluate the results for see how just how reasonable are the results that the team has come up with, and that's something they can help with at the end as well. Now, of course, this is a team approach, right? Generally, our teams consist of those disciplines that you see there on the left. If you're familiar with the cadres, we like to have a core group of subject matter experts kind of on the cadre team to bring all these different teammates together to make these diverse teams as possible. Each of those individuals is going to bring something different to the table, right? So a lot of times geotechs, we're looking at foundation information. We want to know what's the cohesion, what's the friction angle, where a geologist is more concerned about, well, how did that get there, and what's it going to be like over here, right? So they're going to bring a whole different perspective to the project than what someone else may. A team, is going to be able to come up with a better estimate than a single individual. We say that over and over again, and it's just a better way to get to a good number, a very defendable number, that we have to take forward through reviews and end up making very important decisions with. All right, so talking about preparation, I think someone mentioned going to the archives earlier, so that's a place that teams have definitely found some information. I think Sam and I's risk assessment that we did recently, they could not find the flood wall plans. In their eyes, they did not have the as-built for the flood wall. We basically said, you all got to find those. And they ended up finding them in some pump station somewhere in the back of the closet, right? So you hear stories like that about a lot of other projects. That stuff happens. So make sure that you're, doing your due diligence on that. As you prepare, you also want to develop basic understanding of probability concepts. Some of the stuff that Adam went over earlier. Definitely want to be familiar with relevant case history. So if you have a PFM that you're evaluating and you're aware of where that's happened somewhere else before, it's good to bring up, well, when this happened on, Fontanelle, or this happened on Worcester or something, this is how long it took and things like that. Lastly, be careful of the summaries of others' interpretations and the original information. This could also include like the past periodic assessment from 10 years ago, right? The way that we look at things and evaluate things now has changed substantially over 10 years, I would say. So definitely be aware of it, review it, know what's in there, but let's not go basing our numbers on the opinions of others, from 10 years ago. All right, now for the team elicitation. So this process simply be described as, we're going to make an initial estimate, we're going to discuss, and then we're going to try to come to a consensus or even estimate again if necessary. Going to rehash this as well. Make sure that your event tree, your failure mode is clearly defined and decomposed into events that the entire team agrees upon, and understands what they're actually estimating, right? You want to try to do this ahead of time, if at all possible, prior to getting into the elicitation, the risk assessment. Had a situation recently where I didn't do a very good job of this, and we got to the risk assessment, and someone was uncomfortable with the event tree. We talked about it for an hour and a half, and eventually just decided to move on and come back to it at some other point in time. And that's going to cost us time and money on that project. All right, so here's an example of a potential node that is simply labeled as pore pressures rise, right? And there's a lot of things about this that I don't like. You want to make sure they're interpreting, every team member is going to interpret this the same. One thing this doesn't do is tell you, well, how much I have to place a number on it, pore pressures rise. If it goes up half a PSF, is that going to be a 1 for my nodal estimate, right? So you want to make sure that you adequately define your nodes so that everyone's on the same page. And if you have to break this out into, other branches coming off that node for different levels of rise, then, don't be afraid to do that. All right, so the most important thing that we do to help elicitors to make these estimates is putting together the more and less likely table. For those of you that have been on PA, you've done this before, 2-column format. Each team will offer up factors, right, on the more or less likely side. You want to discuss those factors. If you don't agree with the factor that somebody put up on the more or less likely side, then don't be afraid to say, hey, I'm not sure I understand why you think that's a more likely factor. Let's not have things up there that don't belong there. Be sure and document it. Don't be afraid to, type a little bit extra for that particular factor to make sure that everyone understands it the same. A little bit about scalability. So for the semi-quantitative risk assessment, right, we're doing one table for the entire potential failure mode. In a quantitative risk assessment, you're going to do one table for each individual node of the event tree. So if you have 7 nodes in your event tree, you have 7 more and less likely tables. Typically shorter, right? But you would have 7 tables for more and less likely factors, 1 for each node of that event tree. Now, as you're kind of reviewing these more and less likely factors, you want to make sure that whatever you write down, you might have to do a little digging or chasing or background for it, right? So things that might be said or reported somewhere sometimes need looked into. Had a situation where a set of plans once said that sand boil 2008 adjacent to the Levee toe, and so we put that on our more and less likely table, right, on our more likely side. And after we got to digging and looking around, and even called the flood fighter that was out there in 2008 and talked to them, there was nobody could recall that ever happening, right? So that was one that didn't carry a whole lot of weight in the end, but at the beginning really seemed like it was going to be a very strong factor. So here's an example of a more or less likely table for a quantitative assessment. This is for a node in our overtopping PFM event tree, head cut regresses to crest. You'll notice that they have bolded 2 things on the left for this one. So just by looking at this one, you would kind of assume that, they probably think that the head cut's going to begin right off the edge of the crest. And it certainly looks like, they put more weight into the the wind dam C analysis, maybe so than they did the deal breach analysis listed on the right. So this is a common thing that we want you to do, is to, as a team, discuss once you've got all your more or less likely factors listed down, discuss them, decide which ones carry more weight, bold those, right? And if someone bolds something that you don't know why they bolded it, you know, say, hey, I don't understand why you think that's a strong factor. Make sure we're all kind of getting on the same page with this. Okay, so often when we do risk assessments and we have new teammates, and it's their, you know, they're being requested to provide numbers, they really don't know where to start. So this is the table. There's been some studies that have been performed to kind of arrive at these descriptors relating to these probabilities. But in general, this is what we would say. So, hey, here's some guidance for you. If you think something is neutral, right, you're going to put a 0.5. If you think something's likely to occur, you're looking at 0.9. If you think there's absolutely no chance of it happening, right, the lowest that we typically will ever go, it's like 3 orders of magnitude down, virtually impossible there. If you find yourself, you know, putting virtually impossible on a node, you do want to consider the potential that, hey, maybe there's too much combined in that node, and I should potentially split that node out into 2 nodes, or think of a different way to potentially attack that, right? Because we're not very well calibrated down to that level. Now, as far as eliciting the probabilities, some of the quantitative risk assessment, right? Everyone does their own individual estimate for the APF. So that's the chart there on the left. The team agrees on what the critical loading is, right, prior to making their estimates. They have the AAP of that loading. They keep track of their individual nodal estimates, multiply all those together, figure out where they land, right, and then share it with the team. For quantitative risk assessment, it's a little bit different. So in general, we're going to evaluate each node independently as we go, starting with, you know, node 1 and progressing through. And you're going to be evaluating multiple stages concurrently. And you're also going to be providing what you believe to be your lowest reasonable value, your most likely value, and your highest reasonable value, right? So, you know, I think we mentioned this already. Each team member makes their initial anonymous probability estimate on their own before hearing, you know, anybody else's numbers, right? That's one way we can eliminate bias, so that we're not letting the loudest person in the room or the most experienced person in the room kind of dominate where our numbers end up at. You definitely want to be open, you know, as you reveal your numbers and are listening to other numbers. It's really easy for people to, you know, be thinking about what they're going to say about their numbers and not even listening necessarily to what someone else is expressing about theirs, right? So definitely time for doing some very active listening and being open to, you know, the potential that maybe you weren't thinking about it the right way, right? Now, as estimates come out, there's a few things that can happen. The facilitator is going to, you know, basically start trying to get the team moving towards a consensus. Some things that can happen are, you might have a situation where everybody is kind of clumped together around a common number. There might be a couple of groups of people, and there's potential that you have a couple outliers, right? So facilitator, and a good facilitator is going to generally call on those that are on the high and low ends and kind of see what they were thinking and see if everybody else is kind of on that same page, right? If they're not, then it's up to the rest of the team to kind of point out, why they were and why they don't think that their number is necessarily representative for the project. It's very easy for teammates a lot of times that are on the higher low end for the first thing that they say to be, well, I can come down or I can come up. That's not what we want, right? We don't want that to happen. We want you to think about why you made your estimates and describe it, right? If your thoughts were not aligned, that's fine. We'll work through that, but don't just assume that you need to come down or up because of you being an outlier. So, adjustments to the probability estimates. So it might be that some teammates could be having a difficult time converting their degree of belief into numerical value, right? That's very hard to do. Maybe there's a piece of evidence that someone thought was something else and didn't quite clearly understand. That could be the case. If everyone's kind of in the same, interpreting the information the same way, if the numbers are clumped together, it could mean that they're interpreting it the same way, but you still need to discuss it to make sure, right? Because there could be different ways kind of getting to that same answer. So when we're making adjustments to probability estimates, you want to try to come to a consensus, but it's not necessarily, required that you do so. You'll find that we found that, trying to use the team median is typically a good place to start. This is, going to kind of eliminate some of that bias from potential outliers, as well as kind of forming a little bit of like a central tendency, for the numbers for the data set that was estimated. One thing we did not recommend doing, is to take the range of numbers that the team elicited, taking the lowest low and making that the low, and the highest high and making that the high, right? That can lead to some unnecessary uncertainty or skew to the values that end up getting used in your actual risk assessment calculations. So generally not recommended to do that. All right, so some of the issues with documenting term results. One of the things that I think we see quite a bit is, we talked about bolding, more and less likely factors, right? A lot of times we'll have situations where the bolding doesn't match up with the estimate. And what I mean by that is, you might bold something on the more likely side, and then your estimate is neutral or unlikely, right? And if that's the case, then you probably need to go back and work on your bolding. Maybe there's nothing wrong with unbolding some factors after you've been through the elicitation if those didn't actually turn out to be key factors, or perhaps it's a situation where maybe some teammates weren't weighting some of the evidence in the same manner as some of the others. The rationale. So, not only is the more and less likely table important, but we do document the rationale, right, for each potential failure mode. And you want to do a good job of explaining how you got to where you did with the estimate. We're going to have to, do it in such a way that if someone else picks it up 10 years down the road, they kind of know what you were thinking, right? They're able to decipher what the team was thinking, where they were with some of the individual nodes, and how they got to where they did with the estimate. Now, let's say that you're having trouble coming to a consensus, right? This is okay. This is actually not a bad thing. One of the things that this does is it can help lead to recommendations. There's often, pieces of information that are out there that could flip things from one way to the other, or have a significant difference in where you might end up with your risk estimate. And so if that happens, there's nothing wrong with going to your vertical team or to your stakeholders with a chart like this, where PFM1, we think it's going to land where the pink box is, but if we're wrong about our assumption of the uplift, then it's going to be like 2 orders higher, right? So a situation where you could easily come up with some recommendations to go figure that out. All right, coherence checks. So you want to do coherence checks typically after the end of each failure mode. You want to see where it lands and kind of go back through and make sure it's not plotting too high or too low, or maybe it's way off from what you expected, right? And if that's the case, you got to think about it. Had a situation early in my career where we ended up plotting really high for a PFM. We thought, how was this plotting so high? So we started looking back through, and it turns out, some of the lower pools that we had evaluated, their frequency was kind of driving the risk. So we went back through our numbers, looked at our system response for those pools, make sure we felt good with them, and moved out with it. And that one's in construction, I think, this summer. So in conclusion, subjective probability, it draws on the background and judgment of the elicitors rather than on fully objective data and calculations. There's nothing wrong with using calculations, right? Just know what went into those calculations, what the uncertainties are with the parameters of those calculations. But be prepared to, certainly pull on your judgment and your experiences as you do this. More and less likely factors, right? It's a primary method that we utilize to help teams prepare for estimating. Make sure that you conduct your first round anonymously. And then lastly, facilitated discussion. That's where you're going to do most of the documentation of your rationale and kind of guide the team to getting to that consensus estimate.